This presentation will review how we use structures for databasing. As you will recall, we use structures to store data when the fields have different attributes or types. Each structure can then become a data type, and we can even construct an array or matrix of these structures. Given that, it's a useful tool for developing classes and objects. You will also recall that we have experimented with a date as well as a calendar with our initial look at structures. Well, let's take it a step further, and instead of making a date a simple structure, let's form a date class, since we'll be able to use a date in a number of applications, not just a calendar. So, we would still use our structure for date record, where we would enter a day, month, year, and create a string date. And we could also have a private variable then called date record, the date, and add functions for entering the date and then returning either the day, the month, the year, the long format of the date, or a short format of the date. We could even add functionality where we could have a span of days between two different dates. We then looked at a calendar class which used a time. Now, time.h is a variable that's already used, and we don't want to confuse what we're doing here with some built-in functionality in C++. So, what if we were to create a clock time class? Now, I left the E off because I like to stick with the 8.3 naming convention for the name of a class, where we'll have 8 letters.h or 8 letters.cpp when we name our header and implementation file for a given class. Let's take the idea of a time. We'll continue to use our structure, one time, where we have hour, minutes, seconds, whether it's daytime or nighttime, AM or PM, and the time zone. In our private variables for the class, we would have one time, the time, and then we would have access to functions for entering the time, and then returning the hour, the minutes, the seconds, whether it was AM, PM, the time zone, and we could even look at a duration. How long is it between one clock time and another clock time? One can imagine we could also have an interesting time doing this when we had a day and a time, but that's for another day. Then we could have a calendar class. So what we would do is we would have an event, but instead of declaring the structure for date and time internally to the class, we would use the classes in this particular class as well. So we would have struct event, where we could then have an event name, an event date, the location. Notice we're having a clock time for a start time and a clock time for a finish time, a place for remarks, and so on. We would have private variables for the number of events in our calendar, and then a vector of events called myCalendar. Then we could develop a number of different public member functions. For example, we could enter an event, sort the events, print out a calendar, delete an event. Perhaps we could even do things like determine if we had a scheduled event on a given day. With all these capabilities, we can see that structures are not only useful in a one-time program, but are useful when we want to define an object or some repetitive type of program we would use numerous times, like date and time. Now, we'll do a little bit with our calendar, but our real focus for the end of the year will be our last major program, and it's to build a database. And that database will be a grade book, where we'll keep grades for all students in a given class. The gradebook will then allow us to add, edit, or delete students, add, edit, delete assignments, search, sort, and generate reports, and then save and reload the database. To do that, we're going to think in terms of what information would I have in a gradebook for one student. For example, in my gradebook, I could identify student ID, a student's last name, first name, middle initial, gender, class, and by class I mean senior, junior, sophomore, freshman, the class hour, and the number of assignments for that student with a vector or a list of all those assignments, as well as information pertaining to those assignments, an average grade, and a letter grade. Now you'll notice that we have a vector of each grade called all grades. That means that for each assignment we'll have a number of different items of information. Note that we had to include int number of assignment so that in our structure we'll know ahead of time how many grades or assignments to look for when we make a vector that contains all of the assignments for a given student. Now, to start out in a simple form, each grade then would have an assignment name, an assignment type, for example, test, homework, so on, a due date, a point value, how much is it worth, a points earned, how much did the student earn on that assignment, as well as a place for remarks. Now we could get more complex, but this will give us a pretty good little database when we start putting this together for all of our students. Note that the vector each grade, all grades, would be a list of all the assignments for a given student. Now, we would have to declare the structure for each grade prior to declaring the structure for one student. Otherwise, we'd have an error because we couldn't use each grade as a vector type unless we had already declared one. Then, when we have one student defined, as well as each grade and the assignments list for all grades assigned, we could create a class called Gradebook. We would have two private variables. The first one would be a vector called this class. Each element of the vector would be equivalent to one student. So we basically have a list of one students for this class. We would also have to keep track of the number of students. Now, when we do this, we would want a main menu or a sequence of things that we could do when we use our gradebook. This menu will actually go in the main program, not the gradebook. And each of the menu items then would represent a public access function for the class. So, to enter a student, we would need a function in the gradebook.cpp for entering a student. The same can be said for saving a gradebook, open a gradebook, add an assignment, add a grade for the assignment, search, and we'll limit our searches right now to finding the last name of a student or searching for an assignment. We might want to delete a student, delete an assignment, and by delete I mean taking them out of the database. We'll talk about drop an assignment here in a moment. We might want to sort our gradebook by last name, by gender, or by average grade. We might want to call up and edit a given student's information, particularly the demographic information. We could also generate reports by looking at a class report to see how the whole class performed on all assignments. This will end up looking very much like a spreadsheet. We could also generate a student report for an individual student. And of course, we might want to exit the program. And that'll be interesting because, as you know from your use of programs such as Microsoft Word, when we exit a program, we might save over top old data. In other words, we would save our information. We might save as to save a copy under a different name so we don't lose a previous edition. Or we might exit without saving, and we'll investigate that as we develop this program. When we're done, we'll think about how we might drop an assignment, which is an interesting puzzle, because drop an assignment will mean that we could designate a different assignment for each student that we might drop from their grade. For example, give them a benefit of the doubt, drop the lowest grade, something of that sort, so that we could actually have the assignment on the books, but it wouldn't be counted in the average. To put all this together, you'll need 5 files as we get started. I'll provide you with date.h and date.cpp. I did it rather quickly, so you might have to do a bit of debugging, but it should be a pretty straightforward exercise. You will develop gradebook.h and gradebook.cpp for your gradebook. And then oneclassgrades.cpp will basically be a gradebook program which would allow you to open a given class, add students and or assignments for that class, and then save it. This oneclassgrades.cpp is basically the user or main calling program that would use the gradebook and as an object or as a class to do most of the heavy lifting. The oneclassgrades.cpp basically would be a large menu and switch which would allow you to make selections from the member functions in gradebook. Now, as you saw in a previous slide, we're being pretty generous with the due dates. It's a busy time of year. However, each of the functions that you saw there will be at least 100 points and could make the difference between 1 or more letter grades if you don't get it completed by the end of the year. To get started, you're going to develop your date class, which I will provide you, debug it, make sure it's working, and then you'll develop the gradebook class header where you place the structures needed. Then develop your function prototypes and private variables. From there, you'll start with a checklist on the menu by beginning with your constructor, setting the initial values for private variables, and then proceeding to build one function at a time. Don't wait for due dates. Get ahead as fast as you can, because as you know by this time, there are interesting times ahead when you find that one little error that you just can't solve, and it may take several days. By working quickly and working ahead when you can, you'll have the opportunity to pad your schedule with time needed for that kind of debugging. You'll develop the test program as you go, and we'll get a sample database going so that once we've entered several students, we don't have to keep entering the same information over and over again when we develop our actual application. We'll be able to test a given set of data. Okay, your final product is going to be a gradebook that looks, acts, feels, and functions like a database. And the functionality that we will have will be able to create, update, and manage records, as well as generate reports for a student or the class. This is your last major project. I will have an update on how we'll handle our portfolios. We will spend some time towards the end of April and the beginning of May building a notebook of examples with algorithms and information that we've used frequently this year, so that you'll have that as a programming reference. But I want you to place a lot of emphasis on this program, and I want you to get started early. For those of you that procrastinate, you'll find yourself in a real bind and not doing as well for this college credit class as you'd hoped to because you didn't start early. So use your time well, use it, go quickly, move ahead as quickly as you can on all stages of the program, and leave yourself a little bit of time at the end in case you have other things to be concerned about. Okay, let's get started.